A hydrogen atom goes with inelastic head-on collision with another hydrogen atom, and it seems that one of them emits a photon. So in order for that to happen, what should be the minimum kinetic energy of our initial hydrogen atom? So when the inelastic head-on collision happens, some energy is lost. So we have to assume that all that lost energy is given to one of the hydrogen atoms that then emits a photon. And if it has to emit a photon, it should go to at least one excited state. That is, it should go from the n is equal to 1 to n is equal to 2, so that it can jump back from 2 to 1 and emit a photon. So let's start from there. To emit a photon on de-excitation, electron must jump at least one level above first. So it will get that energy from and that energy it will get from inelastic collisions energy loss. So now let's do the calculation. So change in kinetic energy. So that is the energy which is the loss of kinetic energy, and that is given to one hydrogen atom which emits a photon. So energy of that photon is 13.6, 1 by n1 square minus 1 by n2 square, which is 10.2 electron volt. So on head-on collision, this much energy should be lost. So for inelastic collision, we can write our momentum equation first, which is mv. So v is the, let's say, the initial velocity. So then both of them will move together, let's say with velocity v dash. So this gives v dash is equal to v by 2. And loss of kinetic energy is equal to initial kinetic energy, which is half mv square, minus half into 2m into v dash square. So from here, if I put v dash is equal to v by 2, I get delta ke is equal to 1 by 4 mv square, which is half of mv square by 2 or ke by 2. So delta ke is ke by 2, and from here we have seen delta ke is 10.2. So from 1 and 2 we get the initial kinetic energy. The minimum initial kinetic energy should be twice of 10.2, that is 20.4 electron volt. Our answer.